Okay, so as a reminder, you do need to pause as you go through things to try it on your own. So this is the factoring. I'm going to go ahead and do this part of the factoring. This is not a lesson on how to factor. This is just going through some examples. As once again, you should have already watched the video that Ms. Adonic made, as well as done the Florida Virtual School lessons, or looked up on your own if you needed more help with factoring. So this first example we have is what's known as a quadratic trinomial. So the first step we do here with the quadratic trinomial is we multiply our a times our c term. We also then identify our b term, which is this middle thing here. So that's where I get the 1. What we're going to do now is we're going to try and find what we call our magic numbers. And I want two numbers that multiply to give me negative 30, but add to give me 10. When I think of 30, my first thought is 3 and 10. But I know there's no way to make that add to be 1. So I'm going to say, oops, nope, let's try again. Then I start thinking, I'm like, well, to get 30, I could also do 5 and 6. Those are actually only 1 apart. So if I say 6 minus 5 equals 1, well, hey, that works there. And if I do 6 times negative 5 equals negative 30, that works there. So these are my magic numbers. What we're going to do with that, because they add to give us your b term, you're actually going to substitute them in for your b term. I call this busting apart your b. Once again, we can do that because 6x minus 5x is x, where you are able to just, if you combine these, that's what you have. It's just a perfect substitution there. Bring down the rest of my polynomial. Now I have 4 terms. 4 terms is really important because as soon as we have 4 terms, we can go ahead and factor by grouping. When you factor by grouping, you put the front 2 terms in parentheses together, you put the second 2 terms. Notice that this negative that was with the 5 stayed there. Our magic number was negative 5, so the negative stayed with the 5. I'm now going to try and find the greatest common factor in both of these groups. So for this first one, the greatest common factor is 3. I know that because it goes into both of them, as well as x. Both of them have an x. So when I do 3x squared divided by 3x, I'm just left with x. When I do 6x divided by 3x, I'm left with 2. Over here, once I'm going to try and find that greatest common factor, because there is this negative here, I know that I must pull it out. If there's ever a negative in this term, go ahead and factor that out. Also looking, I see they're both divisible by 5, so I'm going to bring that out as well. Now, negative 5x divided by negative 5 is x. And then negative 10 divided by negative 5 is 2. I know I've done this correctly because my parentheses match. If your parentheses don't match, then you know you've done something wrong, but here they did match. So when they match, I'm going to take my 2 greatest common factors, so that 3x and that negative 5, and I'm going to put them together, and they became one of my factors. Those matching parentheses, you just take it once, and it becomes your other factor. Now, I do want to remind you that if you want to double check your answer, you can multiply this out and you'll get what you started with. So that's a reminder that we did factoring to take it from standard form to factored form, but you can multiply it to take it from factored form back to standard form. So that's a check for yourself. Now that we have looked at this, now that we've done A, which was a factor by grouping, I'm actually going to move to C because it's also a factor by grouping. I know this because there's 4 terms. 4 terms we saw right here at this step as well, and so we know that that is what we're doing. So we're going to go ahead and group again, and pull out those greatest common factors. So I see that this one, there isn't a coefficient on the x cubed, so I know I'm not going to pull out a number. But I do also see that they both have at least 2 x's, so I'm going to pull out an x squared. X cubed divided by x squared is x. 3x squared divided by x squared only leaves me with the 3. When I come to the second one, once again, I have this negative here, so I immediately know I'm going to pull out that negative. I see they're also both divisible by 4, so I'm going to pull that out as well. Negative 4x divided by x, well, the only thing that's left is the x. Negative 12 divided by negative 4 is 3. We can see, again, that we know we're doing this correctly because our parentheses are perfectly identical. If your parentheses aren't perfectly identical, that's when you need to try again. So I can take those GCFs and make them into a parentheses. I can take what was the matching parentheses and make it the other one. Now, this is where most people would want to stop, but we're not actually done yet. we have a little bit more to do. And the reason why we have a little bit more to do is because of this right here. If you have an exponent in the inside, so once again, you have an exponent on the inside of a factor, that means that you should see if you can factor further. So I look at this, and I know that x squared is a perfect square. And I know that 4 is a perfect square. And because I know that, I can go ahead and use this as a difference of squares. And I can use this as a difference of squares by saying, okay, x, I'm going to write x in 2 twice. And then I'm going to bring that x plus 3 down. So once again, what happened there was this was a difference of squares. I know because there was this 2 here I tried. They were both perfect squares. Because they're both perfect squares, I can take those square roots and put them in the parentheses. And then put a plus sign in one and a subtraction sign in the other. But I also didn't want to forget about this x plus 3. I brought it down. All right, so the next one we're going to look at is b. So whenever you just have the 2 terms, you want to ask yourself, is it a difference of squares, or is it a sum or difference of cubes? Well, immediately, because this is a plus sign, I know it can't be a difference of squares. I know it can't be a difference of cubes, which means my only choice is a sum of cubes. I'm going to check and see if it's a sum of cubes by seeing, are these perfect cubes? Just like in the last one, we looked for perfect squares. This one's looking for perfect cubes. So I'm going to say the cube root of 8x cubed, well, that's equal to 2x. I know that because 2 cubed equals 8, and x cubed equals x cubed. So that's what I did there. I also want to check then for the 27. Well, the cube root of 27 is 3. What that means is 3 cubed equals 27. Now, I did those really quickly, and that's because I have a lot of my information memorized. In class, I told people that you should have your perfect squares memorized through 15. So you should know up to 15 squared. And then you should have your perfect cubes memorized through 6. I'm not going to test you on that straight out, but you're going to see that they show up a lot in your factoring problems, and it's going to be super useful to know them. So the answer is yes. Because both of these are perfect cubes, I do have a sum of cubes. What that means is that I need to be able to use my sum of cubes formula. Now this is something that you guys need to have memorized. It's the sum and difference of cubes formula. And it goes something like this. I'm going to do it in a different color actually. Okay, so this is your formula. And so part of the question is, well, what is this A and the B? Well, this is my A, and this is my B. I found those. So whatever was the cube root of your first term is your A, and whatever was the cube root of your second term was your B. So that's how I was able to find those. And now that I have them, I need to be able to put them into this formula. So I'm just going to go ahead and write those first. I see it's A, which is 2x, plus or minus, I'm going to leave that open for now, b, which was my 3. I'm going to go ahead and move to the next parentheses. It says a squared. So once again, I'm just using this formula, a squared. And when I'm over there, so a squared is going to be 2 squared, which is 4, x squared, which is, well, x squared. Once again, it says plus or minus. I'm going to leave that blank for now, just move on. So it's going to be a times b. So 2x times 3 is 6x. And then it's plus. Notice it didn't say plus or minus, so I know that it is going to go ahead and be that plus sign. So it's plus and then b squared, so just 3 squared is 9. So the last question then we have is, what goes here? Well, once again, we had these as plus or minuses. It's obviously going to be plus or minus. The question is just what. So we actually have an acronym that helps us out with our signs. It's SOAP. So you see I wrote that out really far. SOAP stands for S is the same, O is the opposite, and then the AP is always positive. And you can tell they're always positive because we don't even put the minus sign as an option there. It's just a plus sign. Same and opposite is dependent on what you had in the original. So since the original was positive, when I say same, I mean positive. Because the original was positive, when I say opposite, I mean negative. And this is my final answer. Now, I've had some good people be like, yo, Miss Sample, it's got that 2 in there, though. It's got that exponent. You said to check that. You said as soon as there's an exponent, we need to see if it goes further. And you are correct. However, if you have done a sum or difference of cubes, and you've done this entire formula out correctly, it's not going to reduce further. This quadratic right here is not factorable. We can't make it go further. So this is, in fact, your final answer. So once again, when you've done a sum or difference of cubes, even though there is an exponent on the inside, you're still done. All right, we have one last question. Let's use green. We haven't used green yet. So this one I see once again is 2 terms. My question is it a difference of squares or is it a sum or difference of cubes? Because it's a subtraction symbol, I know that it's a difference if it's one of these. So now I'm going to say, hey, are these perfect squares or perfect cubes? But I use my brain knowledge and I look at it and I go, 32, maybe 32 is a perfect cube. You know, I'm still kind of learning those. But I know 18 is not it's not a perfect cube nor a perfect square. So I'm really lost. But then I say, wait, hold up. We forgot about our GCF. And the GCF is that greatest common factor. So when you're having a hard time factoring, you're like, what do I do? Go look at that GCF. And so I see they're both divisible by 2. And also they both have at least one x. So I'm going to take those out. So 32 divided by 2 is 16. I had 3 x's, I got rid of 1, so I now have 2. 18 divided by 2 is 9, and I took that x out. Now when I look at it, I'm like, oh, it's a difference of squares. I know that because the square root of 16x squared is 4x. The square root of 9 is 3. So using that pattern we already saw, I'm going to write 4x and 3 in a parentheses twice. One of them gets the plus sign, one of them gets the minus sign, and then also don't forget about this 2x we had here. He comes on down. And that is my final answer. So, like I said, this is kind of a really quick review of factoring. You had multiple different ways to do this. Miss Adonic did a video that went through the graphic organizer. We also had in the supplemental folder all of my old notes from years past, as well as the Florida Virtual School lessons on it. If that wasn't enough, you can always go on Khan Academy and then come and see me during office hours. This is going to be the end of the first video. The next videos are going to look at graphing.